Good morning, students. Can you able to see the PPT screen?
Yes, ma'am.
So in the previous class, we were discussing about the secondary storage devices. Then we discussed buffer. We compared to the various types of secondary storage devices and their capacity, access time, maximum bandwidth, and the commercial price of the products. Then we were discussing about storage organization of databases. At last, we discussed the buffering of blocks. So any doubt in the previous class portions? So today we are going to discuss about buffering of blocks. So if you take the buffering of blocks, it is used in main memory to speed up the transfer from disk to main memory. So usually we are using the buffers in between the main memory to the secondary storage devices. Before processing the data in the RAM, the data will be stored in the prefetch state. The data will be stored in the buffers. So we are using double buffering also, where CPU can start processing a block once it's transferred to main memory is completed. So after processing the data, doing the calculations in the main memory, using arithmetic and logic unit and control units, the result will be again transferred back to the buffers. It permits continuous recording or writing of data on consecutive disk blocks, which eliminates the seek time and rotational delay. So if you are using buffers in your processing, that will avoid the seek time. Seek time means the time we need to access the data from the memory and storing the data in the accumulators, doing the process, again transferring the data, result back to the buffer. Seek time means how long we need, how much time we take to access the data or to process. Again, after processing, how we are transferring back to the transferring or storing the data in the designation place. By using the buffers, we can avoid the seek time as well as rotational delay. Why? Because the data will be available in buffers before processing. So we'll access the data from the buffers. Immediately we can start doing the process. So that is the main advantage of using buffers. The diagram shows you how the actual processing happens using the buffers. Say here, interleaved concurrency versus parallel execution is shown for your understanding purpose. So if you are using the interleaved concurrency of operations A and B, so we are performing two operations, operation A and operation B. Initially, the operation A will be loaded in the CPU at the time slot TT. After executing A, the result will be transferred back again to the buffers. The time to access the value of A and processing, again transferring back to the buffer of result A. In between, we have some time. So during that time, the processor will be in ideal state, because the processor will not be used for any other. It will wait for the process A to complete. Then after transferring the result of A, only the process B will be loaded into the processor. But if you go for parallel processing, parallel execution of operations C and D, so what will happen here? It will, while processing A, the value of B will be stored in the buffers. Once the completion of A, the value will be taken back from the values of B will be taken. Parallelly, the B process will happen. So that is the main advantage of, we can avoid the wastage of CPU time through the buffers. Say here it shows the disk block input output operations. Fill A, so it will access the value of A. Then fill B, the value of B will be accessed. Then the processing will be done in the time slot I+2. Then the value will be returned back to the buffers. If you go for the disk block processing, A will be processed at the time I, and then it will take the value of I+1 at the time B will be loaded. Then A will be processed I+2 and B will be processed at the time interval of I+3. So in that case, the CPU time will be wasted. If you go for buffers, it will avoid the wastage of CPU time. How we are managing the buffer means, the buffer managers views the available main memory storage as a buffer pool, which has the collection of pages. So the buffer is a memory place where it can store the huge amount of data from the available collection of data. The size of shared buffer pool is controlled by the database administrators. So which data we can store into the buffer and which can be transferred for CPU will be administrated by the buffer manager. There are two kinds of buffer managers. So one controls the main memory directly and as it most RDBMS. So we are having two types of buffer management. In RDBMS, what we are doing, we will take the main memory directly. The tables which we are going to process in relational database management system will be controlled by the main memory directly. If you take the second one, allocates buffer in virtual memory, which allocates the control to transfer to operating system, where operating system returns control. So we have two types of buffers. So the size of the shared buffer pool is controlled by the database administrators. So if you go for virtual memories, where we can store other, say if your buffer capacity is only 500, say 128 GB. So if you go for the virtual memory concept, double the amount of data can also be stored in the virtual memory space, where the virtual memory is a logical space. Virtually it will be available and it can be used for processing. Once the processing is over, the data can be transferred back to the physical memory. So up to this we discussed in the previous class. So if you take the goals of buffer manager, to maximize the probability that the requested page is found in the main memory. So searching for the particular data or a page in the main memory can be managed by the buffer managers. So say if you are executing a program, the program is having two matrices. The values of the matrices will be readily stored in the buffer managers before actually processing the matrices. So it means searching for the variable, what is the initial value, how transferring the value from the secondary storage device to the main memory, seek time, access time, searching time, all those things are eliminated through buffer managers. In case of reading a new disk block from a disk to find a page to replace, that will cause the least harm to the sense that it will not be required shortly again. So if you are using a number of pages in your processing, accessing a particular page, storing it for processing the buffer, again storing back the result, all those things are taken care by the buffer managers. So it will avoid the wastage of CPU time, waiting time, accessing time. All those things will be eliminated through the buffers and buffer managers. Buffer manager keeps two types of information about each page in the buffer full. So if you take the buffer manager, it's maintaining only two kind of data in the about each page. So actually buffer means where we can store a collection of data, a memory place where the object code or a collection of tables can be stored in the buffer manager. If you go for the buffer manager, what it will do, it maintains about each page data. So it's taking only two parameters about each page. The first one is a pin count, the number of times that page has been requested, or the number of current users of that particular page. So if a number of people are accessing the same page again and again, so that will be kept in the buffer manager for a long time because it's most frequently used. So it maintains the pin count, how many times people are accessing the particular page. If this count falls to zero, the page is considered unpinned. So nobody is accessing a particular page for a particular day. So it is the pin count is zero. Then it is that will not be in the pin. Say if in our laptop, if you are using a particular page, the page will be opened and it will be available in the tab. So if you click on the tab, it will show pin, unpin, quit, or close the particular page. All those options you will get. So if you are accessing a particular page again and again, that page will be available in our tab for easy access. Initially, the pin count for every page is set to zero. So the initial pin count, how many times a particular page is accessed, will be zero only. If I am using a particular page 10 times, so you can see in the laptop also most recently used, or you can see in the if you open a folder, in the folder option you can see recently accessed files or recently opened folders. So through that, within a particular day, which page we accessed so far, that can be easily accessed through the latest used pages. So far, any doubt? Incrementing a pin count is called pinning. So if you are accessing a particular page 3 times, 4 times, the pin count will be 4 or 5 times. And each time you access the particular page, the pin count will be increased. So the pin count, increasing of pin count, accessing the particular page for a number of times is called pinning. In general, pinned block should not be Screen is visible to you? The PPT screen is visible to you all. So we are discussing about the goals of buffer manager. The idea behind using buffer manager is to avoid the CPU memory, CPU time, and CPU main memory usage. While using the buffer manager will take care of the buffer access, which data we can store it in buffer, and we can make use of double buffering also. And virtual memory, some RDBMS packages are using virtual memory concept to store and access huge amount of data. And while using the buffers, the buffer manager will make use of the buffer count or pin count. The pages which we are using or accessing often will be stored or pinned in the buffer manager. So each time when we access a particular page, the pin count will be automatically incremented. Initially, the pin count will be in 0. If you access the page one time, or if you access a particular website or a particular Word file or a exe file, it will be counted once. So each time, say, but within a day, if you are accessing 10 times, pin count will be 10. Once the pin count becomes 0, it will be pinned out from the buffer. Incrementing the pin count is called pinning. The concept of accessing a particular page and maintaining the count of pin is called pinning. In general, a pinned block should not be allowed to be written to disk. So if your data is in pinned 1, it is in current usage. So once the count becomes 0, then only it will be stored back to the disk. Until if it is in use, it will be in the pinned folder only. So that is the use of buffer manager and pin count. And we are using a concept called dirty bit, which is initially set to 0 for all pages, but it is set to 1 whenever the page is updated by any application program. Say in operating system, you might have studied least recently used, most frequently used pages, page replacement policies, all those things. The same concept is used in buffer manager also. Buffer manager has the following 2 responsibilities. Make sure that the number of buffers fit in main memory. So whatever page or data which we are accessing, that should fit into the buffer. Say if the buffer manager capacity is only 8 bits or 8-bit buffer, it can occupy only 8 bit of data. If the buffer capacity is 16 bit or 32 bit or 64 bit, according to the capacity of the buffer manager, the data will be loaded into the buffer. So the make sure that the number of buffers fits in main memory. So whatever data we can store it in the main memory, that much amount of data alone will be stored in the buffer manager. Say if your CPU is 16-bit, you can at a time it can access only 16-bit of data. If your CPU is 16-bit, but if you are using a 32-bit buffer, then the data will be kept pending in the buffer itself. If the requested amount of data exceeds available buffer space, the buffer manager must select what buffers must be emptied as governed by the buffer replacement policy. So if the data capacity exceeds the buffer space, say you are trying to store an 64-bit of data into a 32-bit of data. So which data we can store and which data we can store it in the next state can be fixed by the buffer manager, or the unnecessary data will be eliminated from the buffer and the necessary data will be stored by using the buffer replacement policy. If the buffer manager allocates space in virtual memory and all buffers in the use exceed the actual main memory, then the common operating system problem of trashing happens and pages get moved back and forth into the swap space as the disk without performing the useful work. So if your buffer capacity is only 16-bit, but if you are trying to load on 32-bit data, then the space exceeding excessive data is coming to buffer. So that in that case, we'll get the operating system trashing problem. So in that case, to manage the trashing problem, the swapping of pages, cleaning the unnecessary data from the buffer and moving back the data to the disk and eliminating the unnecessary data and making use of the space effectively can be performed by using the swap space operation. If the page is not in the buffer pool, the buffer manager does the following. So if you need some data immediately for next processing, but the data is not available in the buffer, so the buffer manager will take care of how to access the necessary data. So it chooses a page for replacement using the replacement policy and increments its pin count. So if the data for processing is not available in the buffer, what it will do? It will go and search for the data and it will replace the content of buffer with the necessary data and the pin count will be incremented for the particular page. If the dirty bit of the replacement page is on, the buffer manager writes that page to disk by replacing its old copy on the disk. If unnecessary data is available in the buffer and you need to store some important data for next processing, what it will do, the data from the buffer will be transferred back to the disk by using the dirty bit replacement page, and it will load the necessary data in the buffer and make use of it for processing. If the dirty bit is not on, the page is not modified and the buffer manager is not required to write it back to the disk. If data is not in the dirty bit is not in the buffer, and if the buffer is in empty state, the page is not modified. The content will not be modified and the buffer manager is not required to write the data back to the disk. If the buffer is free, nothing is written in the buffer, it means the dirty bit is not in the buffer. Then no need to transfer or clean the content of buffer, and it will continue to store the necessary data and it will continue the process. So if some data is in buffer, then it will make use of the replacement policy to replace the content with the necessary data. And if the buffer is free, it won't do anything and it will load the necessary data into the buffer and it will start doing the process. So these are the two main operations performed through the buffer pool. It reads and requested page into the space just fed up. The main memory address of the new page is passed to the requesting application. So whichever data we want to use for the processing in the main memory, that data will be loaded into the buffer and it reads the requested page into the space just fed up. So the necessary data will be read from the pages and it will be loaded into the buffer. So in this way, we are managing the buffers.
So any doubt with respect to the buffer management? We started with buffer management. We know very well buffer is an intermediate memory in between main memory to the secondary memory. The next data to be processed by the main memory or the CPU will be loaded into the buffer. Each time when we access a particular page and load the page into the buffer, the pin count will be maintained. The buffer managers take care of which data to load into the buffer, and that is going to be used by the main memory. And if a data is loaded in the buffer, it is called pinning. Each time we access a particular page, the pin count will be automatically increased. And if some unnecessary data is stored in the buffer, that is called dirty bit. But that data is not necessary for the next processing. In that case, the buffer manager will replace the dirty bit by the necessary data. So the content of buffer will be transferred back to the actual memory space of the secondary storage memory space of the particular data. And the necessary page will be loaded into the buffer. So for that purpose, we are making use of the page replacement policy. And the buffer managers make use of virtual memory concept also, so that if the capacity of the buffer exceeds the actual data, in that case, we can go for virtual memory space where the logical memory will be created that will avoid the trashing. If there is no unpinned page available in the buffer full and the requested page is not available in the buffer full, the buffer manager may have to wait until the page gets released. So we are waiting for some data. The data is not loaded in the buffer. So it means the buffer is waiting for actually the data bus will go and read the data from the secondary storage or in the secondary memory. The data will be read from the secondary storage and that will be transferred through the data bus. Through the data bus, the data reaches the buffer. While processing, the buffer content will be loaded into the RAM and the actual processing happens in the microprocessor. Once the processing is over, the result will be transferred back to the buffer, from buffer to the disk storage. Each time while executing any process, the buffer should contain the next data to be processed. So any doubts so far? Can you able to see the PPT screen? Any doubt? The PPT screen is visible to you? So far we discussed buffer management. Next comes buffer replacement strategies. Here buffer means the memory which is available in between main memory to the secondary memory. Any doubts so far? The next concept is buffer replacement strategies. So we have different types of buffer replacement strategies. First one is called LRU. What is LRU? You studied operating system in your previous semesters. Second one is called clock policy. Third one is FIFO. What is FIFO? Any idea? Pawan Kumar, what is FIFO? You might have studied LIFO, FIFO. Akshit, Sai Vaibhav. Can you able to see the PPT screen? Because there was a lot of network issues.
Yes, ma'am.
So if you take the buffer replacement strategies, here buffer means the memory that memory is available in between the main memory RAM to the secondary storage devices. And replacement means, so if some data unnecessary, that's what, whenever we use any variable, initially we will declare the variable. And if the variable is already used previously in some other programs, say for example, you are using a variable or called student name or student registration number. If the same variable name is used in 2-3 programs, in some programs, in some languages, once you come out from the program, once the program is closed, the content, the memory allotted for the particular variable will be re-allotted. The label will be erased. Say we have some variables like student USN number, student name, department. These 3 variables we are using in 2-3 programs. So the first program you are executing, you are storing some value in USN number, name and department. The second program also you're doing with the same variables, USN number, name and department. So if some value is stored in those 3 variables, if you don't initialize the variables in the second program, the old values will be preserved. So you may get some wrong information while executing the program. That's what in every time in C, C++ and all, we will initialize first we will declare the variable, and we will give the visibility of the variable, say whether it is a public variable, protected variable or private variable, and some initial value also be assigned to the variables. If it is in class, whenever we initialize an object, the corresponding implicit constructor will be executed, and it will assign the initial value and memory to the variables depending upon the data type. The same way, we are using buffer replacement strategies. Say list recently used pages. If a particular page is not used for a long time, unnecessarily keeping the particular data in your computer or mobile may waste your memory. And if some apps are not used from a long one, fast 1 year, if there are so many files with the same name, same information, some pictures are duplicated so many times, sent and received so many times. So you can find some pictures of 10 copies of the same picture, more than 4 or 5 copies of the same folders. You may download it again and again. So that may waste your memory and duplication may occur. So to avoid those kind of memory wastage, we are using the concept called the least recently used proc policy. How often we are accessing FIFO means first in, first out. The same first in, first out means we will call it as FIFO is queue or stack. FIFO is called first in, first out is called queue or stack. The person who goes first will get served first. Is called queue. Last in, first out means if you put it in a stack, the last bill you punched into the bill counter will be taken out first. Or if you take the CD rack, the last CD, topmost CD will be accessed first because it is in one way. The same way we have most recently used, which files we are often using, which apps daily we are using. Say some of the apps like WhatsApp daily we are accessing. Just say some apps like LinkedIn Learning or Upgrade or so many other web pages. You may have installed some apps, but you may not used it for a long time. While installing initially, when you come to know about the particular app, you may install and use it 1 or 2 times, but it is in unused state more than 6 months, 7 months. So while cleaning or checking for viruses in your mobile, so that time it will show these 5 apps are not used for more than 3 months, 6 months. You want to keep it or you want to delete it, and these files are duplicated for 5 times. So you want to clean. These are the temporary files. These are the unused pages, or these are the huge files, video files, audio files. So like that. So the unused data should be cleaned, and it should be the memory and should be kept it for future usage. So that will automatically increase the efficiency and speed of your computer. So the same way we are using the buffer replacement policies. If the buffer is having some data, which data to keep in buffer and which data to not to keep in buffer. And if some data is used often again and again, no need to transfer the data back to the disk and accessing the data from the disk. Say, for example, if you are having a reading table or in your home, you have a reading disk. So in the reading disk, you will keep all the, so every day you may be using pen, you may be using pencil or something, that will be kept in your table itself. Some books you may use rarely, so those books will be kept in rack. When you are using the book or when you are using a particular document, so you'll go and take the document from the shelf, keep it in your table, use it. Once it is over, again you will keep back the book or records back to the rack. But most oftenly used pens, pencils, or any tapes, all those things will be kept it on your table itself, so that whenever you want, you can access it. It will be in reachable space to your hand. So the same kind of policy is used in operating system as well as in the memory usage. So these are the most four commonly used techniques. Buffer replacement strategies. So if you take the buffer replacement policies, like a page file, placing file records in a disk, how we are placing the files and records in a particular disk. So where the disk will store your data permanently, records and record types. So based on the records and record types, we are storing the, based on the type, we can store the data, or based on the record, whether it is this semester data or last semester data. So according to that, the data will be ordered. So data is usually stored in the form of records. So you might have used, you are using labs. This semester also you may have 2 labs, lab records you are using. In the lab record means, you can see in the lab record first page, index sheet, where you will find the columns, serial number, date of the experiment, the description of the experiment, then page number, marks awarded, remarks. So that is a typical example for any a table or record. If you take the DBMS table or RDBMS table, or even ORDBMS or OODBMS tables, MongoDB or anything, table means it will have rows and columns. The rows are called tuples, columns are called entities. So we'll give some typical name. In general, Max will say rows and columns. So each, with respect to each row and each column, a particular cell will have some data. So the data is usually stored in the form of records. Record means, in general, rows and columns. With respect to 1,1, that represent a particular cell. If you say 5,4, that represents a particular cell in the 2-dimensional axis. Each record consists of a collection of related data, values or its items, where each value is formed of 1 or more bytes and corresponds to a particular field of the record. So a particular field is called entity. So to represent entity only, we are creating the entity relationship diagram, or we'll call it as schema. Schema means, say if you take the value student name, whether the student name belongs to a particular 6th semester or 5th semester or first year, whether the particular student name belongs to computer science department or civil department or mechanical department. So each entity is associated with another entity through some relationship. If all the data in the particular record will be interrelated, there will be having some relationship, hierarchical relationship. So it means a particular student belongs to a particular department, he belongs to a particular semester, he is in the odd semester or even semester, whether he belongs to A session or B session. So each and every parameter, each and every field is interrelated. Records usually describe entities and their attributes. So each record means a row of values, entity represents its attribute. Every student will have its own user number, name, department, semester, section, subjects, labs, internal marks, external marks. So each and every field is associated with each and every person. So that is called records usually describe entities and their attributes. So attributes means the user number, name, department, semester, section, all are called attributes. Or we will call it as in classes, we will say attributes and functions. So each student class will have all the attributes. On each student object, we can apply all the functions. So attributes means what are the characteristics associated with the particular real world object. So data types of a field is integer, long integer, floating point, string or characters, fixed length or varying length, Boolean, having 0 or 1, true or false values. So each entity Entity means each attribute or each column. Say if they take the value as USN number, the USN number is character type. Why? Because it is having a 19 BTR. 19 is number, BTR is alphabet. Again 00101. So it means it's combination of numbers along with alphabets. So it is a character data type. So we cannot say it is an integer. Why? Because it's having alphabets also, BTR, CS. So it is numbers with alphanumeric characters. So it is of character type. Integer means pure integers. It means with fraction or without fraction. Long integer means it can store 16 bits of data. So you have the basic data types now. Integer means only 2 bytes. Long integer means 4 bytes. Float means 4 bytes. Long float is 8 bytes. String means only one. String means collection of characters. Each character will have only 1 byte. Fixed length or varying length. Fixed length means the size of the character is fixed. Say if you say USN of 10, it will accept only 10 digits. If you say unsized, USN within brackets no size, so it will accept only 3 digits or it may accept 50 digits also. And Boolean means true or false, 0 or 1 values only. So these are the data types which can be assigned to any entity. The number of bytes required for each type is fixed for given computer system. So how many bytes we can assign for it depends. Say in C, C++, Java, in all languages, the number of bytes, the integer means 2 bytes, and character means 1 byte. Long integer means 4 bytes. Float means 4 bytes. Boolean means 1 bit. So the size of the data is fixed. In some database applications, the need may varies for storing data items that consist of large unstructured objects. So if you are storing an unstructured data, say the if you are collecting the data from the social media, the comments from Facebook or Twitter. So in that case, the comments may be in audio form or video form, picture form, emoji form, or it may be in PDF file or Word file. So in that case, if it is an unstructured data, in that case, we will consider it as an object. Based on the object, it will assign the, if it is a video, according to the size of the video timestamp, the memory will be allotted. Why we are using this data types and the length of the data types means we don't want to waste the memory. So if you declare a variable as alphanumeric character, it will accept both integer as well as float as well as characters also. But we cannot, in characters, we cannot perform the arithmetic operations. It will take a long, the precision you will not get, the accuracy you will not get. But if you make an integer as float, then the data will be in always with fraction points. If you make some data as only integer, it will not accept fraction values. So depending upon the nature of the variable, we are fixing the data type and we are fixing the how much memory we need that we are assigning. So any doubts so far? Buffer management and how we are assigning the values? So any doubts? Okay, no doubts means mention your attendance in the chat box. Okay, I will upload the material in the Google Classroom. We just previous class video clippings also I have uploaded. Just to go through the content. If you have any doubt, you ask me in the class. Akshit Reddy, Ajay, Pavan Kumar, Shrikar, Amina Begum, Sai Vaibhav, Banu Prakash. Answer your attendance. Once you answer, you can leave the class.
Thank you.
Devika Menon, Alini, Arshita, Jayasurya, Mrudul, Nitish, Patan, Pravar Jain.
Yes, ma'am.
Yeah, answer your attendance. Mention your name and your in the chat box. Nitish, Prakash, Santosh Kumar, Sheikh Hena, Shivam Gupta, Anil Sai, Vishnu Reddy, Vijay, Akif, Neeraj Sain. Yeah, all of you answer your attendance. Arvind Gowda, Rahul, Shadan, Shagar, Shashank, Akash, Karunya, Olivia, Samak Jain, Sandosh Raj, Rakshit Jain, anybody in class today? I told the electrician to, I think in the 127 class, the PowerPoint is not, we have 2 pins. In one pin, the power is working, another pin, the power is not working. Okay, all of you answer to your attendance. Shall we end the class? Thank you.